All right, ladies and gentlemen, we are going to get started on the second part of part 3, working on event systems. Now, event systems are there to allow us to pass messages back and forth between emitters of events, things that generate events, and other objects in the scene. So anything in the scene can receive an event from an emitter. These objects, we want them to be able to communicate with each other without having to explicitly know about each other. As we saw in our scripting system, when we were originally putting things together, we were passing object references around so that they would know about each other. But when we talk about an event system, we don't necessarily want these objects to even know that the other objects exist. Now this is going to be a powerful concept that will allow you to build modular as well as high quality games. For this, we're going to use a free product, third-party free product from a company by the name of TigerForge as the basis for ours. Now don't let the free price fool you. This is actually a quality product. It is well received by the community and it is free for you to use in your products. TigerForge also makes a number of other free products that you can integrate with your system for saving games and so forth. So with that, let's go ahead and get started. Once we get done with the event system, we'll be able to move on and do more complex things with our games. Alright, so back in Unity, the first thing we need to do is get our asset installed. So we need to go into the asset store and look for TigerForge, which is the asset that has our event system. Now if you do a search for TigerForge, Tigerforge, you will find a variety of assets. As I mentioned earlier, they have something for handling file saving, object pooling, browsing prefabs. We're really interested in this event manager. So we go to the event manager, we would do an import. I've already imported this project, but you would have imported it once it is downloaded. You will find TigerForge here, as well as a few demos. So everything that you need is already going to be in this particular asset. So let's go into our scene, but before we really start creating stuff, let's chat about what an event system or what this event system would do. We can get a good idea for that by taking a look at the documentation. If we go to the asset store, we go to this asset, we go all the way to the bottom, there is an online manual. You can click on that and come up in your browser, and here is the documentation for TigerForge's Easy Event Manager. The methods are all very straightforward, as is the case with most event managers. They are deceptively simple to use. There's a lot that's taking place under the covers. So there are three primary things that we want to be doing. We want to start listening for events, which is what this method is for. So we tell the event manager that I want to start listening for an event. We'll give it an event name that we want to start listening for. If we want to listen for a large number of events, we can have a group set up so that we can listen to multiple events and then start listening. The other thing that we can do is we can stop listening. So if we are no longer interested in events for whatever reason, maybe we've received the event, we're done what it told us to do, and we want to stop listening so that we don't receive that event more than once, we can stop listening. The other thing we may want to do is emit events. So if we are an object and we want to emit events to other objects, this is where we would do that. Now an event can have all sorts of data in it, a wide variety of custom data, and that custom data can include floats and strings, as well as game objects. You can have all sorts of things in there. So here is a case where we're emitting an event that has a game object in it, so that something that receives that event will be able to get my game object, extract other information from it, and potentially cause that game object to change in some way. Now if we want to send or receive complex data, we have a mechanism called set data group. So we go to the event manager, say we want to set this data group and put all of the data that we want to send with that event. And on the other side, the the object that receives that event would just then say, I want to get the group data and extract it out as an array, because that's how it arrives. So in this case, we have an age, we have a Boolean, which is saying whether or not we can attack, what the power of that attack is, a game object that we are getting the event data for and turning it back into a game object, and a string, as well as some other variables here that we're passing along. So we can pass along any arbitrary number of items that make up complex data that can be received by something on the other side, and unpack it and do something intelligent with it. Another thing you'll want to do, because it will enhance your performance, and it's just plain useful to be able to do this, is you want to be able to filter events. So for example, if you want to send an event to everything that's a game object, anything that's listening for a particular event, but you want to filter it down for one type of thing, the emitter can send along some metadata that will help the system make sure that event is only delivered to the intended targets. So for example, we're looking at here in the documentation, the event manager is emitting an event called IAmPlayer. So anybody that listens to the IAmPlayer event will receive this, but he's stipulating that they have to have a tag called player. So there are three things that you can use to discriminate how you want that event to reach something. You can use a name, you can use a tag, or you can use a layer. So in this particular example here, the name is anything, and this supports wildcards as well. So the name is anything that has play in it, the tag anything that has super in it, and layer 0 being the default layer. So if you only wanted to send this event, say you had an enemies layer, and you only wanted to send this event to the enemies in the enemies layer, you could target that event to that specific layer, and only those things in that layer that are capable of receiving that event would be able to get it. Now conceptually, event systems are useful for building things where you have known objects that want to speak to other objects within the scene. But one thing that you don't want to overlook is that you can also have events emitting events that are intended for other systems. So for example, suppose you have a system that plays music. It knows how to play music, it just needs to be told what tracks to play. In your world, you may have a jukebox object, and when the player interacts with that jukebox object, they may select a particular track. That jukebox object would then emit an event into the world, and your system that plays audio, and that's all it knows how to do, would listen for that event, process it, pull the track out, and then start playing audio. Another thing that you might do for that is look at like time of day. So there are lots of different types of games that have day-night cycles, and what you may want to do is that at certain times of the day, which one of your systems, which handles the day-night cycle, would know, it could then send an alarm or an event out to the rest of the world that the lights should come on. Now, this is just a generic event. The daylight system is going to say it is nighttime. It's going to broadcast that out to the world, and everything that wants to listen to that event would be able to react to that. So the lights could hear that event and then say, we want to be active as opposed to inactive. And then when morning comes, they listen to a morning event that comes from the day-night system, and then they turn themselves off accordingly. Now we'll look at two scenarios when we start looking at these scripts. One, we're going to have a simple object that's going to listen to a simple event, and another where an object receives complex data and uses that data that it receives from an emitter to change itself based on the data which is included in that event. So now that we've talked about the theory of how that would work, let's kind of put that into practice. So let's go back to Unity, go back to our scene, and let's go ahead and build a scene where these objects will be able to emit events and respond to events. So let's go ahead and create a box. I'm big on using primitives so that we don't get ourselves caught up in over designing things this early in the game. And we're going to call this player. Player, not payer. And we'll go and create a sphere, and we'll call that target A. We'll move that off to the side, and we'll create a cylinder, and we'll call that target B. Now we'll also select our camera and Control-Shift-F so that we are looking at our objects. And now we're ready to go ahead and start building some scripts that will manage events from these various components. Now, one thing that I've gone ahead and done to save us some time, because there's no point in you listening to me typing, is I've already gone ahead and created these scripts, and we'll review them and then add them to the appropriate game objects. So we have the player script. We'll open that. And basically what that's going to do is, this is a standard binary behavior. We are importing TigerForge with using TigerForge. And in our update, remember this is happening once per frame, we're going to look and see if the fire 1 button is down. That would be the left control button or the left mouse button, depending on which you're using to control your game. And then we'll say that we are firing that event, and then the event manager will emit an event called change color. And it's not giving it to anything in particular, it's just sending that out to the world. So let's go ahead and add that to our player object. And we can actually run the game now. And what you'll find is, as we click, we can see in the console that we're firing the event. But there's nobody around listening for that event. So just because you send an event into the world doesn't mean that the event has to be consumed. The event manager is not going to stash these away and wait for somebody to respond to them. If there's nobody listening to that event, they silently fall on the floor and get discarded. So if you send out events and there's nobody currently registered for that event, when that object does register for that event, it will have missed anything that came up to that point. So just make sure that your objects are listening fairly early on in their life cycle if you want to start generating events early within the life cycle of your game. The next thing that we're going to do, so we can go ahead and stop that, because we can see that we are generating events. We'll go ahead and have this color change. Big on the color change. This color change script that will listen for that change color event, and then it will change its color. So in this particular case, the change color listener script, it has a list of listeners. We're only adding one at this point, so it can listen for that change color event. What's happening here is, what do I want to call if I receive that change color event? And so that is referencing this change color method here. Note that there's no parentheses here. This is just the name of the method. So if I receive a change color event, the change color method is going to be called. We're doing this in start because we want this to happen right before the first frame of the game so that we are already listening for the event as soon as our game starts. Now if we do receive a change color event, we'll send out a debug message that says, I was told to change my color, and then I will go ahead and change my color. Now let's go ahead and add this particular change color script over to target A. So it is now the target of the script that is generating the event change color from the player. Now we can go ahead and run that. Now that we're running, we go ahead and switch over to the console, press the mouse button, and what we see is we fired off that event. The other object has received that event and outputs that I've been told to change my color, and it changes its color. So that is the basic of being able to emit events from an object and have other things in the scene listen to it. But suppose we want to do something slightly more complex. Suppose we want to send data structure to another object from something that wants to emit an event. So let's talk about how we do that. Now we have all of the basics for that particular event emission structure already in place, so we should be able to create a third script, and we will just create another C# script, and this will be, call that target B script. And we will add that to target A because that's the guy that received the event. We want to send an event from target A to target B. So we can go back to our player script and we can extract information from it, specifically the event manager emit event, because we want to send out an event, and we want to send that from our color change listener script. So the guy that turned red, he's going to change his color, and then we want to have him send out an event. Let's just say that he is going to send out a changed color event. So he receives a changed color, he's going to send out a changed color event. And what we can do here is we can send over 3 numbers that represent the color that we want to change to. So we will just go with 100, 45, 25. I have no idea what that color is, but on the other side we will change that into a color, and we will change the receiver of the changed color event into that color. So now we are ready to go to our target B script. We can copy much of this over to our target B script, copy that, go to this method, and we can paste that here. Just make sure that we are using Tiger Forge because that's where our event system lives. So we want that to listen to the changed color event, and when it receives that particular event, it will call its own change color. Actually, we just call it something different so you can see that it's different. Just call it different method. So it is going to call the different method, and now what this particular script needs to do is extract the data from the original event, create a color for it, and change its color to that. So now we can go ahead and extract our color from the sender, and what we can do for that, so we were calling different method. Let's just go ahead and move this. We want to get the data, which is event data, and that's going to be from the event manager dot get data group. And we need to specify the event that sent this to us, and that is going to be the changed color. That's the event that we received. And we need to make sure that this is of type var, standard variable data for C#. Now that we've got the data, we want to, semicolon, getting too used to writing Python code. We want to extract out the different pieces, so we want to have a color that we're going to create. New color is a new color, and Unity colors actually take floats. Now we don't want to change our code to accommodate that, so let's go ahead and just get the data out first. Int, the red component will be the first one, and we will say that that is data sub 0 dot to int. That's the first component. We'll say the green is equal to data sub 1 dot to int, and then we'll have the blue component is equal to data sub 2 dot to int. So we're getting all of the data that came along with our event, and now we need to normalize these because we were sending stuff in range of 255, but Unity colors, the actual color class expects them to range from 0 to 1. So we'll just take our red and divide that by 255.0f. We'll do the same for our green. And then our blue. And that should normalize our color for us. And what we'll do then is we will change our color to be the same as the new color that we just created. From that, we're not emitting another event, so we can delete that. So what we have here is target B, whatever this is attached to, it's going to listen for a changed color event, and when it receives one, it's going to call different method. Different method is going to print out to change my color again, so we can tell those apart. Then we're going to extract the data from that event, extract the red, the green, and the blue from that, create a new color based off the data that we received, and we will change the color of this object to match whatever we receive from the other object. So now we should be able to save these scripts and see what happens. Let's go ahead and save target B script and save this change that we made to the color change listener script. We still have an error here. The error is that it cannot convert from an int to a string. So event manager emit event. Let's take a look at that in our documentation. We are sending complex data, so we need to use event manager set data group. And that is fine. So now let's go ahead and run this again. So now we have an event that's firing. We have something that responding, saying that it was told to change my color, but our other event didn't fire. So let's debug that. So the first thing we should do is double check our scripts and make sure that they are sending and receiving the right events. So we take a look at our color change script, and it is now sending out the changed color. Let's take a look at our target B script, and it appears to be doing the right thing. Let's make sure that target B script is actually set up properly on the object. So it is not on player, it is not on target A, and actually it's not on target B. So let's right click on this. This is actually really useful to do if you're ever trying to figure out where your what your scripts are associated with. We can do a find references in scene, and what we're seeing here is that this particular script is not attached to anything. If we were to right click on our player script, we would see that it is on this particular object, so that's useful. So let's go to our target B script. Somehow it didn't make its way to our object, so we'll put it on target B. We need to do that when we're not in play mode. Target B. We go ahead and play. And so in our console, we were told to change the color, but we still don't have our event firing over to our cylinder. So it's got to be something else. Let's see where else we might have an issue. So one of the areas that we can look in now is just to make sure that we're receiving our event. If we pop over to the console, we are told to change my color, and that is something that is in our change color script, but we never received an event from this guy, because target B, the first thing that it's going to say is I was told to change my color again. So that means that we have not emitted the event. Even though we set the data for the event, we still need to emit the event. So this should resolve our problem. We go here. We're setting the data group for the change color event, but we still need to emit the change color event. Let's go back into Unity, let that compile. Okay, so let's stop that and start everything up again. And click. And there we are. So this was actually very useful. One, because you had a chance to take a look at some debugging for your event system. But more importantly, you can see how you can nest events together. We actually had an event that was propagated from this player box that arrived to this sphere. The sphere did something and it sent out another event, and that was received by this cylinder. And so all of that is basically how you would deal with propagating events throughout your game. The system itself is very straightforward to use when you remember to actually emit your events. And this is really going to be fundamental to putting together something that is a large, stable game that's easy to modify, because you won't be tying everything together with these strong links between game objects. You will essentially be emitting events, and things will listen to those events, and that makes for an environment that is easy to scale, easy to modify, and easy to author. So I strongly recommend you take a look at the event system, understand how it works, integrate it into your gameplay, because it's going to be very important. You can use it to generate things to game systems and from game systems, as well as between game objects. Just make sure your scripts are nice and tight, and you should be good to go. That will conclude everything that we have for scripting. We have actually had a chance to review quite a few things during the scripting session, that being our ability to deal with interactions, being able to capture input from the user. We've looked at how to scale that input to be frame rate independent, and we've looked at events to be able to send messages between game objects, and do so in a way that those game objects don't even have to know of each other's existence. All very powerful stuff. We'll use this later on as we start building more complex scripts, but for now, that's it.